Hello, class. This will be the recorded lecture for section 4.3 in our Trig book. And we're going to spend one whole week just going over one section. You'll see that there is a boatload of different more identities and formulas that we will be introducing and using, and then trying to tie all of these formulas into doing some proofs as well. Quite challenging section, but we're spending quite a bit of time to walk through that. And you'll see that there are a boatload of new identities and formulas that we are going to talk about. And here's what we're going to talk about in this section. First one is called the double angle formula. Second one, half angle. And then we're going to talk about the product sum and sum to product formulas as well. And all these are used in different ways to do some calculations. And all of them are useful because the end of the day, what you're trying to do is to either simplify the expression or get an actual value for the expression using all these different styles of formulas. And so the identities we consider, we're going to start with the double angle formula, and a lot of these other formulas get derived from that one. And so let me show you what that looks like. And so here it is. And again, super helpful to get that basic formula sheet off of our Brightspace site and be able to have this all in one place. And you can see that we have double angle formulas for sine, cosine, and tangent. And so again, the three most important, the other three are nice math things, but not used in the real world. And what's nice is the sine has one formula. You see that there. And the tangent only has one formula. But the cosine has three. And it's valuable because there's three possibilities. But for a student, it's challenging because sometimes you want to pick the first one, the second one, or the third one. And you don't know which one to pick until you see what the equation and what the problem is. And if you picked one of the other two, it might not give you the solution that you're looking for. So again, adding some more complexity to an already complex problem that we have. So what I'm going to do is walk through this problem here. And this problem states is that you're giving a value for cosine of x, and that is -2/3. And it also says that you're in quadrant 2. So remember that when we take a look at this, we're in quadrant 2. So it'd be over here. And so let me draw the triangle again, just to refresh everybody's memory, all right? It would look something like that. And this would be -2 for the x value, right? And this would be 3 for the y value. So when you're calculating this, we know we're here. So I'm sorry, not y value. This is the hypotenuse. So what would be sine of x? Well, sine of x would be the y value, right? Divided by the hypotenuse, which is 3. So there's a couple ways to do this. You could use Pythagorean's theorem, right? And we would end up with 3 squared equals x squared, which is -2 squared plus y squared. So when we do this, we get 9 equals 4 plus y squared. So y squared equals 5. Y equals plus or minus the square root of 5. And then you say to yourself, I'm in quadrant 2. Quadrant 2 implies y is positive. So in this case, our answer is going to be positive square root of 5. So we go back up here, and the sign is 5 over square root of 5, excuse me, and not 2, but 3. So then once you have the sine and cosine, let's take a look at calculations for using the double angle formula. Oh, you know what would be handy? Get the tan as well, all right? So let's put the tan up here as well. So tan is y over x, sine over cosine, and so that would be square root of 5 over minus 2. And so that would be minus the square root of 5 over 2. Usually put the minus sign on the top, but either one is fine. So using the double angle formula, with this information we have now, what is sine of 2x? Well, if you look at our formula sheet, it would look like sine of x cosine of x. And so now we just plug the numbers in, 2. And then sine of x is square root of 3. Why do I keep wanting to put a 3 in there instead of a 5? Square root of 5 over 3. And our cosine is minus 2 over 3. So you just multiply all that out and you would get minus 4 square root of 5 all over 9. So when you put this into the WebAssign, again, it wants you to put the exact value. So you're going to put it into it in a fractional form, just like this. What about cosine of 2x? Well, when you plug in cosine of 2x, we have 3 options. Now, in this case, since we're not doing a proof and you have all the values, you could pick either one, and all of them will give you the exact same number, which is a good thing. When you have these 3 choices and you're doing proofs, it becomes a little bit more challenging. So we have 2 cosine squared of x minus 1 is the one that I picked. So what do we have? We have a 2, and then cosine is minus 4 over 3. And then we square that, and then we subtract 1. So if you do that, you get 3 times 3 is 9. And then you have minus 2 times minus 2 is 4. 4 times 2 is 8. So you have 8 minus 1, and so that would be minus 8 over 9, excuse me. So that would be minus 1 over 9. So how would you do tangent? Well, tangent of 2x is this one. 2 tan of x, all divided by 1 minus tan squared of x. So if you haven't realized, a lot of fractions, right? So this would be 2 times minus the square root of 5 over 2. And then what we're doing is 1 minus the square root of 5 over 2 squared. So when you do that, what do we have on the top? Well, these 2 cancel. And you have minus square root of 5 on the top. What do we have on the bottom here, denominator? So this be 1 minus, and so you multiply the 2 minuses, they turn into a plus. You get 5 on the top, 4 on the bottom. So it looks like that would be minus square root of 5 divided by, so this would be 4 over 4 minus 5 over 4, which is minus 1 over 5. And so if you did that, the 2 minuses would cancel and you get 5 square root of 5. So when you take a look on the slides here, you can see I walked through this one as well. And when you take a look at, for example, the WebAssign homework, let me pop that up here real quick and show you that kind of the first part of the WebAssign is given these concepts, calculate sine, cosine, and tangent of the double angle. So again, this is just starting to get you to think on how these double angle formulas are actually used in the calculations. So there's quite a few of those. You'll see that so long homework assignment, you see there's quite a few, 30 some. But again, we only have one homework assignment for this week, one section for this week. Okay, so that ends the first of the recorded lectures, focusing just on the double angle formula.